effectively what is about to happen in the course is that we're going to discover integrals that are basically too difficult to simply anti-differentiate mentally. And eventually these things will probably become a little bit of second nature to you, but at least at the moment, these integrals will be a little bit too difficult for you. So please refer to the PDF that I posted associated with the video. You'll see an integral like this. Okay, you can see there's a little bit of a problem here with the fact that, first of all, we do not just do the antiderivative of 2x, then the antiderivative of x squared plus 1 to the fourth. Because we know that if we did that and we took the derivative to get back to the original, we'd have to do a product rule. So you can't just treat them separately. You can only do that when it's sums and differences. So I want you to just hit pause and just think for maybe 2-3 minutes, maybe 10-15 minutes, about the three integrals on the top of that PDF and what the antiderivatives would be. So hit pause and do that. Okay, now you might have concluded that this was the integral, and that is correct. Reason is, if we take the derivative of that, just to check it, let's check to see, and you'll kind of understand as we go here. 5 times a fifth is 1, x squared plus 1 to the fourth times chain rule 2x, and the derivative of c is 0. So you can see that 2x came from that inner term there in our chain rule. So point being there, that is the antiderivative of that. Okay, then the next one, maybe you want to pause and give that next one a try if you didn't already get it, with 3x squared, and then the square root of x squared plus 1. If you click pause now, that would be good. And just to resume now, I see that thing right there, x squared plus 1. Am I looking at the right one? Oh, sorry. It's x cubed plus 1. That's my fault. I see that thing right there, x cubed plus 1, has, if we were to raise this power up here, this is the chain rule. 3x squared happens to be the derivative of x cubed. So if I raise that to the 3/2 power, because right now it's a 1/2 power, and I put a 2/3 in front of it, well, then now we have the correct antiderivative. Because 3/2 times 2/3, that's gone. X cubed plus 1 to the 1/2, that's that, times the chain rule, the derivative of x cubed would be 3x squared. And then I'll leave the last one up there for you to do. But basically what we're doing here is we're recognizing that in both cases, this thing and this thing happened to also have its derivative sitting right next to it. So effectively, with integration by substitution, we're trying to unravel a chain rule derivative that's already taken place. I'm going to give you a much more formal way of going about these. So if right now you're thinking, wow, I didn't quite get from here to here or here to here that quickly, I'll give you a more formal way of doing it. So we will do x squared plus 1 squared 2x. This one. And like I said before, what I'm trying to do is find something with its own derivative in the question. In this case, I'm going, and we're going to set that equal to a u value, and you'll kind of see how this works in a second. But the basic idea is we want to rewrite this integral in such a way that it becomes something really easy to integrate. Right now, that's not so easy to integrate. You might know what it is, you might not, but they will get more difficult. What I'm going to do is set u equal to x squared plus 1, because I know the derivative of u, du dx, is 2x. Okay, so in my problem, I see this is u. And that's 2x, so that's good, but I need 2x dx. So I'm simply going to multiply my dx over. So du is equal to 2x dx. So this thing right here is u. This is du. So I have u to the second power du. A couple of things to notice about that. One is we've rewritten this problem in a really simple way. The other thing is we've changed the variable of integration so that now we just have to look at u and say, well, what's the antiderivative there? If you're wondering how in the world that thing is the same as that, I would refer you to this, and I would also give you the following argument, which is hopefully compelling. We have something squared times that something's derivative. Something squared times that something's derivative. Okay, now we can simply do the antiderivative of u squared, which is 1/3 u cubed plus c. And after that, we'd say, okay, well, u is really just a placeholder. U was the placeholder for x squared plus 1. So now if you take the derivative of that, you'd have 3 times a third, that's 1, x squared plus 1 to the second, times 2x. And that's what the original problem is. Okay, so I'm going to move on in that PDF to this problem. The integral of x squared plus 1. Very similar question, although you can notice that instead of 2x dx, I now have an x dx. And that's going to present a little bit of a problem. First step always in u substitution is hunt for something that has its own derivative in the question. And we will attempt to rewrite this a little more slickly. The thing that has its own derivative in the question, I say is x squared plus 1. But it's not exactly the right thing. So again, du dx is 2x. If we are starting to substitute in for some stuff, first I see this is u squared. So I know I'm going to have a u squared in my question. But now I need to replace x dx. And the problem for me is I have du is equal to 2x dx. But I only want x dx, because that whole thing, this, you can't see that. I don't know if it works. This x dx right here, we need to swap that whole green unit out, x dx. It's got to go. So the way to do that is simply to solve for x dx down here. So if we multiply both sides by a half, we get 1/2 du is equal to x dx. So now 1/2 du will go in for where the green is. So I'm going to put my half right here and du there. So just to recap, x squared plus 1, that was u squared, there it is. And then the green stuff got replaced by 1/2 du. And now it's an integral that's very easy to do. I have my half here. That's separate from the rest of my integral. And then that would be u to the third times 1/3 plus c, which is 1/6 u cubed plus c, which is 1/6 x squared plus 1 cubed plus c. And if you want to check, just to do the derivative of that, it'll be 3/6 x squared plus 1 squared times 2x. 3/6 times 2, that's 1. Bam, bam. X squared plus 1 squared, x squared plus 1 squared, x. Done. Okay. Let's keep moving with that. You're going to see some questions that are significantly more difficult with u substitution, where take it one step further with the, here the u value didn't work perfectly. But we're going to take that one step further, and you're going to see, I think I'm on about the third page in to the PDF, you see that. And at this point, you might think to yourself, all right, I got the hang of this. Hopefully you've done some of the ones leading up to this problem. And you say, okay, sweet, u is equal to 2x minus 1, because it's always the thing that's inside. Du dx is equal to 2, so du is equal to 2 dx. There's a little bit of a problem here. 2x minus 1, that's good. Uh-oh. We have an x dx, and that says 2 dx. So if I was to rewrite this integral, right now I have u to the half, but I haven't replaced x and dx. First thing is, I can get rid of the dx by substituting in a half du. So I'm going to do that. 1/2 du. And I left myself, obviously, a conspicuous space there. So now we've subbed in for the dx, and the problem is we need to sub in for x. The way we're going to do that is we're going to take this equation, and we're going to isolate for x. So I'm going to add 1 to both sides. U plus 1 equals 2x. U plus 1 over 2 equals x. That is going to go in for x. Okay, so one more time. 2x minus 1, that was u. So u to the 1/2. There's u to the 1/2. dx was half du. Half du. And x became u plus 1 over 2. Now from here, I just box that out. From here, we'll have half. And then I'm going to leave some of this up to you. Actually, let's make that a fourth. And then we're going to distribute that in. That'll be u to the 3/2 plus u to the 1/2 du. And now you can take the antiderivative of each of those and then plug back in for u, and you'll have your integral done. So I'll just leave that for you to finish. The last, well, maybe I'll, one second. So I'm going to skip all the way to where it says use substitution for definite integrals, where we have limits on it. So this would be, I think, the last page. We're going to go from 0 to 1, x times x squared plus 1 to the third dx. And I'll kind of go quickly through this. The only difference is we have limits here. So u is x squared plus 1. du dx is 2x, so 2x dx. I want x dx, so I'm going to have half du is equal to x dx. So now I'm going to do my replacement. Half, so x dx is half du, and that'll be u cubed. Notice I've left my limits off. I'm going to give you two options here. Half, let's see, 1/4 times u to the 4th, and that's going to be 1/8 u to the 4th, which is 1/8 x squared plus 1 to the 4th. And then I'm going to evaluate from x equals 0 to x equals 1. The other option you have is, midway through this question, we could have, right here, we could have just said, okay, you want it in terms of u, let's just go u cubed du, and if we wanted to put limits on here, u is equal to x squared plus 1. So I could just plug 0 squared plus 1 is 1, and 1 squared plus 1 is 2. If I do this one and I plug in just for u's and I never go back to x's, I'll get the same exact answer I got here by converting back to x's. So either you can convert to u's and your limits and plug in there, or you can go back in terms of x and use the same limits.